Section 3.2 is about polynomial functions and so a polynomial function or polynomial of degree n has this form. P of x equal to a sub n x n plus a sub n minus 1 to the x minus n minus 1, and we will all the way go to a1x plus a sub 0. This a sub n over here is the leading coefficient. This whole term over here, a sub n x n, is your leading term. This a sub 0 is called constant coefficient or constant term. This a sub n minus 1, a sub n 2, a1, they're all coefficients. So these are different parts of the output of the function. So let's look at this problem. You have 5x4 minus 3x squared plus x minus 4. The degree is the highest in the polynomial. In this case, is 4. The leading coefficient is the coefficient in front of the highest exponent. In this case, the leading term is 5x squared 4. The constant term is negative 4. And your coefficients are 5, negative 3, 4. Just look at the. So if you were to look at different type of monomial graph, a monomial is just a graph with one term. So in this case, you have n equal 1, like y equal x. This is n equal to y equal x squared. This gives you cubic function y equal x to the third power. So if n is even, you get a graph something similar to this. And if it's n is odd, you get something similar to this. So this is the observation. Polynomial functions are smooth and continuous. And what does the word smooth mean? It means there are no corners or sharp points, and it's continuous with no breaks off. So as n gets bigger, the graph gets flatter near the origin and steep away from it. So I'm going to get some video. So it's going to this red function over here is when x is n is even, and it's going to go from 4 to 20. This blue function over here is when x is odd. So and it's going to go from 5 to 19. You can see as the x gets bigger, it just gets more flatter and smoother. So how do you find the x-intercept or zeros of polynomial? So in order to do that, you have to factor it. So in this case, you have x cubed minus 5x squared plus 3x minus that. Now, if this was not here, the x cubed, we could use quadratic formula to find the. Since this is here, we cannot use quadratic formula. For this one, in order to figure this out, we haven't covered the technique. So go with the formula. So x cubed minus 5x plus 3x9 can be factored out x minus 3 squared times x plus 1 equals 0. So you have x minus 3 equals 0 or x plus 1 equals 0. And if you solve that, you get x minus 3 or x equals. Now, if you think about it, this is the x cubed function. I'm supposed to have 3, 0, 3 x is 4, but I only have 2. The reason for it is because this right here, the x minus squared, that is called the multiplicity of a 0. So let's say this thing is called C. So basically, multiplicity of 0 means the number of the times x minus c shows up in the factorization of p of x. So in here, x equal 3 has a multiplicity of 2 because there's 2 of them. Or you can say this function has multiples of 2 at x equals 3. Since polynomial functions are continuous, we can get an idea of where the zeros are even if we don't factor them. And this is called the intermediate value theorem, or IVT. So basically what they're saying, if P is polynomial function and the function of the P of A and the P of B have opposite signs, then there's at least one number between number C between A and B such that the function of C P is 0. So what does that mean? If my function for values A and B gives me opposite sides, one is positive, one is negative, then by the IVT, the intermediate value theorem, means there exists one number between A and B that when I take the function of that value, will give 0. So look at the picture. So you have A and B. If I was to take the function P of A, I'll get a negative. If I was to take the P of B, I get a positive value. Then by this theorem, you have a number between those two numbers where x equals 0. Now this may have more than one. So there's one over here, one over here. So that's fine. You got it says at least. Yeah. So let's look at an example. So show that P of x equal negative x cubed plus x plus 4 has a 0 between 1 and 2. So in order to do it, you solve for that function P of 1. You solve it, you get 4, which is a positive value. P of 2, you solve it, you get negative 2, which is negative. Well, that's P of A and P of B are opposite sides. But since they are opposite side, by the IVT, there is some C. Now, we don't care what the value is. Between 1 and 2, such that the value of that in this function is equal to 0. Now, that's how the graph is. What happens when the graph has some kind of how does it look like at the end? We know that as every graph just goes bigger and bigger, right? Well, if you let's say that x is getting bigger or smaller, depending if you're going to pass the infinity or negative infinity. What happens to the end behavior? So the question is determine the end behavior of this function 2x cubed minus 4x squared plus 6. So the as x gets bigger, that means either x is going to be positive goes to positive infinity or negative infinity. The p of x will go to infinity too. So to find the end behavior, it has the same exact behavior as the leading term. Okay? So in other way, the leading term of polynomial determines its end behavior. Now, these are all good. How do we graph polynomial functions? So these are our 5 steps to it. First one, factor to find the zeros or the x-intercept. Then you make a table of key points. Now, these key points needs to include the y-intercept, the x-intercept, at least one point between each pair of consecutive zeros. Determine the end behavior. Then you plot the points and connect them with the smooth curving having the correct behavior. And use symmetry as support. So sketch and graph of this x cubed minus x squared plus 9. Now, when I look at this particular, I could pull out an x and have x times square minus 6x plus 9. Well, since this is in quadratic form, I could actually easily factor that out. I have x equal x minus 3 squared. Once it is in form, I could find the zeros. If that equal to 0, solve it. So I will x equals 0, x equals 3. Since it's we said the end behavior in any polynomial is the same as the leading term, you get this is the end behavior. Then make key points. So I made these. So you find the y-intercept. So you have y-intercept in this case as same as x-intercept. You're 0, 0, and you're 3, 0, and you need to find two value, at least one value between. Now I don't need to have this 4 and -1, but it's just good to have it. When I graph it, I get these points. Then I just connect them. Now it says pick the expression that you have following graph. So I look at this graph and I look at where are my zeros. Well, I have a 0 right here between -1 and 2, so I'm about -1.5. I have 1 and 0, and I have 1 and 3. Well, that's 1, 2, 3, minimum, so 3 zeros. And I could work backwards. And now the reason I work backward is because when I factor it and try to solve it, so if I want to find it in the right form, I just go backward. So I have in here I had 2x plus 3, and then I have just x because of 0, and then I have x minus 3. So the answer will be x times 2x plus 3 squared, 3 squared. Okay. So remember in earlier time we talked about absolute maximum. Well, in graph, there's also called local maximum or local minimum, or it's also called local extreme. So f of a is a local maximum or minimum of f if a and f of a is the highest or lowest point on the graph of f near the point. So basically, in here we give an interval. An interval is the highest or the lowest value. Since polynomial of degree n has at most n zero, what that means is if I have a polynomial with a degree 5, that means it has at the maximum number of zeros it could have is 5. Then the local extrema is always 1 minus that. So if it's degree 5, then it has 4 local extremes. Have a good day.